Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about defining a complex number, and how we come about a complex number, right? But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, we know that when you're solving equations using the quadratic formula, say quadratic equations, we know that the quadratic formula says x, right, being equal to, x is equal to minus b plus or minus square root of b squared minus 4ac, all of this over 2a, right? So we know that that's the quadratic formula. So we can see that from the quadratic formula, right, our answer is two parts. And the first part is that we've got minus b over 2a, and then the second part is square root of b squared minus 4ac over 2a, right? So definitely we know that minus b over 2a, right, is real, right? Be it negative or positive, it will give us a real number. But however, now that we know that the square root of minus 1 is equal to I, this implies that this could either be real or imaginary, right? And now this will take us to the definition of a complex number, because now this could either be expressed in the form bi, right? So this could take us to the definition of a complex number, whereby we're saying that a number of the form a plus bi, where a and b are real, and I squared is equal to minus 1, implying that root of minus 1 is equal to I, is called a complex number, right? So a number like 2i is said to be an imaginary number, right? And then a number like 5 plus 2i is said to be a complex number, right? So something else that we have to know is that from the quadratic formula, right, we can see that if one of the solutions, say, is equal to x is equal to plus bi, a plus bi, right, the other root would be x is equal to a minus bi, right? So we see that from the quadratic formula, the roots, they occur in pairs, right? So they occur in pairs, whereby we've got plus d and then a minus d, right? But now when we're in complex numbers, we say complex numbers that occur in pairs are called complex conjugate of each other, right? So now we are saying that the complex conjugate of a plus bi is a minus bi, where a and b are real numbers, right? So the complex conjugate of a complex number z is denoted by z, then we put it asterisk at the top B, right? So we could denote a complex number by the letter z, right? Such that z is equal to x plus iy, where both x and y are real. So now I would like to achieve those questions. And now for those questions, it's just basically the application of the basics, nothing really complicated. Allow me to erase this as well. Okay, so number 1 says express each of the following complex numbers in the form a plus bi, right? So for 1a, we've got 5 plus square root of minus 1, which is 5 plus I, right? Then for b, we've got minus 1 minus root of square root of minus 81, that will give us 9i, right? Then for c, we've got minus 2 plus root of minus 40, that's root of 4 times root of 10 times root of minus 1, which is minus 2 plus 2 root 10i, like this. So that should do it, right? Then number 2 says write down the complex conjugate of the following, So we've got 4 plus 2i, so sorry, 4 minus 2i. So there we're just introducing a plus there, such that it's 4 plus 2i. Then for the second one, it will be minus 9 plus 7i. And for the third one, it will be 3i plus 6. So these are the complex conjugates for each of those. So now let's move on to number 3. Number 3 now says, solve the following quadratic equations using the quadratic formula. So the quadratic formula says that z is equal to minus b plus or minus root of b squared minus 4ac all over 2a, like this. So for the first part, for 3a, we've got z squared minus 4z plus 5 is equal to 0. So it's saying z is equal to minus b, how b is minus 4, so minus 4, that's a 4, plus or minus square root of minus 4 squared, that's 16, minus 4, ac. This is 1 times 5, which is a 5, right? And this is over 2 times 1. So we get 4 plus or minus root of 16 minus 20, that's minus 4, over 2, which is 4 plus or minus 2i over 2. So our answer would be 2 plus or minus I, right? So we either have 2 plus I or 2 minus I is the solution. Then for part B, we've got 5z minus 3z squared is equal to 1 plus 4z. So we have to take everything to one side. So 3z squared plus 4z minus 5z, then plus 1 is equal to 0. Then we get 3z squared minus z plus 1 is equal to 0. Like this. So now if we solve for z using the quadratic formula, we say that z is equal to minus 1, that's 1, plus or minus square root of minus 1 squared, that's 1, minus 4a, that's 3 times c, that's 3, right? Over 2 times 3, which is 1 plus or minus, this is minus 12 plus 1, which is minus 11, so root of minus 11, over 6, which is 1 plus or minus root 11i, over 6, which means the answer that we're going to get is 1 over 6 plus or minus root 11 over 6i. So we either have 1 over 6 plus root 11 over 6i or 1 over 6 minus root 11 over 6i. So this is for number 3. Then now we shall move on to number 4. Right. Oh, okay. Fine. So number 4 says solve the following quadratic equations by completing the sway. So by completing the sway, for 4a we've got 2z squared minus 8z plus 7 being equal to 0. So now if you take out the 2, we've got z squared minus 4z plus 7 over 2 being equal to 0. Then this will be z squared minus 4z plus 7 over 2 being equal to 0. So of course, if we divide both sides by 2, we remain with this. Then if we say z minus coefficient of z squared, sorry, coefficient of z over 2, this is 4 over 2 squared, right, minus 4 over 2, that's 2, so minus 2 squared, which is 4, then plus 7 over 2 should give us a 0. So z minus 2 squared, then minus 4 plus 3.5, that will give us a minus half, being equal to 0. Then z minus 2 squared is equal to half, and z minus 2 will be plus or minus 1 over 2, so plus or minus root of 1 over 2, which means z minus 2 is equal to plus or minus 1 over root of 2. Then z would be 2 plus or minus root 2 over 2. So we either have 2 plus root 2 over 2 or 2 minus root 2 over 2 is the solution for z. So this is for first part. Then for part B, or maybe let me erase this part here. Right. So for part B, we've got z squared minus 2iz, then minus 5 is equal to 0. So here we are saying z minus 2I over 2, we get an I squared, then minus, right, minus I squared, right, I squared, that's minus 1, so minus 1, that's a plus 1 here, then minus 5 is equal to 0, then z minus I squared minus 4 is equal to 0, z minus I is equal to 4 squared here, then z minus I is equal to plus or minus root of 4, and z minus I is equal to plus or minus 2, then z is equal to plus or minus 2 plus I. So z is equal to 2 plus I or minus 2 plus I. So these are the two solutions for z for number 4b. Then now moving on to number 5, we need to solve for iz squared plus z plus 2I being equal to 0. So of course, if we decide to use the quadratic formula, which states that c is equal to minus b plus or minus square root of b squared minus 4ac over 2a, right? We are saying that we've got minus 1 plus or minus square root of minus 1 squared, that's 1, minus 4a is I, c is 2I. So we're saying I times 2I, we get 2I squared, which is minus 2. So that's 4 times minus 2 over 2I, because our A is I. So we've got minus 1 plus or minus, this is 8 plus 1, that's 9, over 2I, and this will be minus 1 plus or minus 3 over 2I. So z is equal to minus 1 plus 3 over 2I, or minus 1 minus 3 over 2I, which would give us 2 over 2I, that's 1 over I, or minus 4 over 2I, that's minus 2 over I. So these are the two solutions that we get for z as for number 5. Okay, so this was just finishing off on the second part of the introduction to complex numbers, whereby we go to define a complex number and attempted a couple of questions to do with complex numbers. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.